All right, welcome back, everybody. Continuing chapter 2, our look at objects and classes. Now, we already gave you a brief overview of how classes and objects interact, how object-oriented programming works. What we're going to start doing today is kind of diving deeper into the different parts that make up a class. Today in 2.2, we're going really in depth, telling you everything you need to know about constructors in object-oriented programming. All right, so let's view the different parts we have that make up a class. Okay, so let's say we're talking about the class turkey. Okay, first thing you have are the data it stores, the instance variables. In this case, looks like we're going to store an int for the size of the turkey and then a Boolean value for whether it can fly or not. Okay, so we have instance variables, and then typically the next thing that comes into class is the constructor, or in this case, constructors. Notice I have three different constructors here, three different ways to make turkey objects to instantiate them. And we'll talk about why we'd want more than one, kind of how you work with more than one. That's what we're dealing with today. And the last thing would be the methods. We're not focused on the methods today. We'll say methods not shown. We'll talk more about that in the next lesson. So let's take a look at that first constructor from the turkey class. A couple of things about it. Notice that the constructor has the same name as the class. Okay, so when I want to create a turkey object from the turkey class, I'm going to call the constructor. It's basically a method called turkey. And the goal of the constructor is to set the properties of the object to the initial state. So we want to actually instantiate those instance variables with values. And the way the constructor will be called then is if we want to make a turkey object, we'll say we're making something of turkey type, and this would be in a different class, in the runner class. We'll give it a reference name, such as bird. We'll say equals new, and then we're going to call the turkey constructor turkey with the parameters passed in 5 and true to set those instance variables to their initial state. Okay, in most cases, or in a lot of cases, structures are going to have parameters. And the parameters allow data to be passed into the class so that it can be assigned to the instance variables. So in this case, we have, for the first constructor, the int s for size and Boolean c for can fly as my parameters. And then the way they work is I'll pass those in, such as we'll call new turkey 5 true, and then it's going to set within the constructor the values of size and fly to 5 and true. Now when I do this, when I actually make the call to the constructor, the number of parameters and type passed in must match with the parameter list found in the constructor name. Okay, so for example, I can only put an int here because that's what the constructor says I can do, and a Boolean in the second spot because that's how the constructor defines it, okay, in the parameter list. I couldn't mix the order up. I couldn't throw a double in instead of the int. Okay, I've got to stick with the way the constructor is defined. And then again, what happens when I call that constructor, when I say turkey object with a reference bird is equal to new turkey 5 comma true, what that does is Java sets aside a space in the memory and gives it a reference bird. And like we talked about in the last unit, the space bird hold on to the address where the turkey object is stored. So then Java within its object heap is going to create a object of type turkey and set its size to 5 and can fly equal to true. You would see that bird is a reference variable that refers to the turkey object. Now, when we first started talking about this turkey class, we noticed that there was multiple constructors. There's 3 of them. Anytime you have more than one constructor or more than one of any type of method, you're overloading that constructor or method. So here we're dealing with overloaded constructors. And the reason you want to have more than one is that so I have different ways to create the object based on different amounts of information I pass in. So for example, the difference between the first 2 constructors, the first one we've already looked at, I pass in an int for the size, and then a Boolean value for whether that turkey can fly or not. And in my second constructor, I don't have a parameter for the Boolean value. So if I create this object with just an int, the s, it's going to set the size to S, but then by default, set the fly value to false. Okay, maybe there's a lot of turkeys we know that aren't going to fly. Rather than passing a false in, we can just pass the int in, and then by default, the false gets set to false. So once again, overloading occurs when we have more than one constructor for the same class. And the key for making overloading work is that each constructor has to have a different parameter list. If we had the same parameter lists, Java wouldn't know which constructor to call. So I can't have two different constructors that both take in an int and a Boolean value. They have to have different lists. So once again, the number of parameters and data type matters. If you goof that up, you may not be able to actually call that constructor correctly, or you might call the wrong constructor, okay, by passing in the wrong information. So let's take a look at another example of creating some turkey objects. So same line of code we've seen before, turkey bird equals new turkey 5 true. That's going to create a turkey object with a reference variable of bird and set the size to 5 and that it can fly equal to true. And then the next line, when I call my single argument constructor, turkey will say fat bird equals new turkey object with just a 13 passed in. Java's going to automatically go to that second constructor that just takes an int. It's going to make a reference variable fatBird, and with that second constructor, we set the size to 13, and by default, that constructor set the fly value to false. So again, Java automatically calls the correct constructor based on the parameters you pass in. Make sure you're passing the correct stuff in when you make the calls to the constructors. Now our turkey class had a third constructor. Okay, so one more constructor to talk about. And I'm going to say this last one is what's called a no argument constructor. Okay, that just means that the constructor has no parameter list. So we don't pass anything into the parameters. Now, even though there's no parameters, all the instance variables in the class still need to be assigned values. So why would we want to have something like this? Well, let's say we have baby turkeys that when they're born, they're less than a pound. They have a size of 0. They can't fly when they're babies. This allows us to quickly create those types of turkeys without worrying about passing in a 0 for the int or a false, okay, for the can it fly. And then we'll call the no arguments constructor the same way we did with our other constructors. We'll say turkey, we'll name it skinny bird equals new turkey. And since I'm not passing any parameters in here, Java's going to know automatically to use that no arguments constructor, which sets the size by default to 0 and can fly set to false. All right, speaking of no argument constructors, we can also talk about a default constructor. Okay, if no constructors are defined in a class, Java will provide one default no argument constructor. Okay, so you get a constructor for free if there's no other ones. And the way you'll call it is just class name with parentheses, no parameters, just like we'd call a default constructor if we defined it in the class. And as far as how Java is going to assign values for that, all instance variables get assigned the 0 value when you call the default constructor. Okay, so as in ints and doubles get assigned 0 automatically, a Boolean would be assigned false. Okay, any type of objects like strings will be assigned num values to begin with. So let's look at a few other simple classes to talk about that idea of default constructors. So I have a dog class and a cat class. Now notice my dog class has a constructor defined. Therefore, it does not have a default constructor. If I want to call the no argument constructor just dog with parentheses, that wouldn't work. That constructor doesn't exist. Okay, whereas with my cat class, notice there's no constructor defined, therefore it has a default constructor. I can call cat parentheses, even though it's not written there. That's really the only way I can make a cat object to use in other parts of my program. So again, a few lines of code for you here. I could create a dog called dog1 using the dog constructor that takes the breed and the color. That would be legal. I could not say dog, dog2 equals new dog with that no arguments constructor, because again, since the dog class has at least one constructor defined, there will be no default no arguments constructor. Now, could we write a no arguments constructor that would work? Yes, but there wasn't one in the class, so I don't have a default one given to me. Okay, the cat class, on the other hand, did not have any constructors defined, therefore it has a no arguments constructor, and really that's the only way I can create a cat object is by using that no arguments default constructor. Next thing we're going to talk about is the difference between declaring and instantiating an object. Okay, and to do that, we'll start off by talking about primitive values first and remind you how declaring versus assigning works. If we're dealing with a primitive value type like an int, we can declare it only in a line of code. Okay, so this would tell Java to set aside a place for an int value called a plus and just not assign it at all. We could declare and assign in one line. Okay, so in this one line, Java sets aside a spot to hold an int called a plus and fills it with a 99. Okay, or if our variable's already been declared, such as up top, we can assign only and fill that spot in the memory referred to as a plus with the 56. Objects are going to work basically the same way, except for here we'll talk about the difference between declaring and not assigning but instantiating the object. I can declare an object only, okay, declare it on one line of code and then instantiate it later. Okay, so this would be making a space to hold a reference to a turkey object and then actually filling that space with the reference later. Okay, or like we've been doing, I can both declare and instantiate in a single line. Again, very similar to what we've done with variables with primitive types. So what happens in Java when I declare only and don't instantiate the object? Well, what we're going to end up with is a spot in Java's memory that's meant to hold a reference to a turkey object, except for it doesn't actually have the address of that object because that object doesn't necessarily exist here. Okay, so bird is a reference, and we'd say a reference variable that does not contain the address of any object is called a null reference or a null pointer. Okay, null pointer, because back to the diagrams we looked at a while ago, we had the reference pointing to the object. Okay, this reference doesn't point anywhere. This address is empty, so that's why we call a null reference or a null pointer. So again, when we just declare an object without instantiating, such as doing the line turkey bird, we end up with a reference variable bird that references a turkey object that isn't actually pointing to an actual object. When we follow that up with a line of code bird equals new turkey 5, that's going to actually create the object. That's going to then store the address where that object is located in Java at the reference variable bird. Okay, so now my bird reference actually points to an object. We can also run that same process in reverse by kind of unreferencing an object. We'll say you can also assign a reference variable the value null to erase its memory of its former object. So here, if I say turkey bird equals new turkey 5, we'll get the reference variable bird storing the address of a turkey object, okay, pointing to the turkey object. And then if I run this code, if I say bird equals null, what that's going to do is that's going to reassign the bird reference to nothing. It's going to eliminate that pointer. Now bird is a null reference, okay, just like if we declared it without instantiating it. All right, now things get a little tricky in Java when you start thinking about the difference between a reference variable and the actual object. So let's take a look at a line of code, a couple lines of code I have here. First line, turkey bird 1 equals new turkey 5. Okay, so I'm creating a turkey object with size 5. And in the second line, we're saying turkey bird 2 equals bird 1. Now, why would we want to do something like this? Maybe what we're trying to do is make a copy of bird 1. Okay, make a second turkey with a size 5. With variables, that works. You can copy the value of the variable, but it's not going to work for objects. Let's show you why. What the first chunk of the line of code does is it creates a reference variable, bird1, referencing a turkey object. And the right half of the equation is pointing that to a new turkey object with size 5. When I run my second line of code, doing turkey bird2 equals or gets bird1, what that does is it doesn't copy the properties of this turkey object into bird2. Instead, what it does is it copies the address that was stored at bird1. So essentially what happens then is it just takes the reference bird2 and points it at the same bird object. Okay, so what I have here by running these two lines of code is not two different turkey objects. I have two different reference variables, both pointing to the same turkey object. Okay, so two different references to the same object. We'd say both reference variables contain the same address of the same object, or we could say are pointing to the same object. Let's take a look at an example that demonstrates that difference between references and the actual objects we just talked about. So for that, let's look at a different simple class. Let's call it the counter class, okay, a class for counting. It's going to store one instance variable, an int called num. When I create the object with a no argument constructor, it's just going to set num to 0. Then I've got two methods. The add method, that's just going to add 1 onto the num with the num++. And then print num, that's just going to print out the num. Okay, so I have a way to add to that original number and then also print it out so I can see what it is. So let's take a look at some code that's going to highlight the difference between references and objects. And then also I want to show you the difference between the way objects work and get stored in memory compared to our primitive variables like ints, doubles, and booleans. So we've got some code for that. First line is going to create two int variables and store some values in them. So when this first line runs, what Java is going to do is it's going to go to its place designated for memory. We can think of it like a bunch of slots. When I run int num1 gets 5, it's going to name one of those slots num1, and it's going to store the value of 5 in that slot. Okay, same idea with num2 gets 7. It's going to name one of these memory slots num2, and it's going to store 7 in that slot. For my next line of code then, we're creating an actual counter object, counter count1 gets new counter. What it's going to do is, again, it'll go to these memory slots. It's going to name one of them count1, but it's not actually going to store the counter object in this slot here. What it's going to do is it's going to create the counter object off in the memory heap. So we have a counter object, and the constructor set the num value of that counter object equal to 0. Whoops. Num equals 0. And then what actually gets stored in the slot here is the address of that object. We'll call it 123 Fake Street. Not sure what it'd actually be called. We'll just make up an address, 123 Fake Street. So essentially this memory spot is pointed to the object. It's referring to the place in Java's memory heap where that object is created. Switch up colors here quick. All right, so moving on, When I start running code then, additional code, num2++, that's going to take 1 and add it on to what's stored at num2. So now stored at num2 is an 8. When I do count.add, remember what that does is just adds 1 on to the counter object's num value. So now we'd have a 1. Count1.add again would cancel out that 1 and make it a 2 stored in that object. All right, now here's the difference. When I say num1 gets num2, we're going to reassign what's at num1 with what's stored at num2. Right now there's an 8 stored at num2, so we're going to cancel out what's at num1 now and store the 8 there. And then when I do something similar with the counter objects, we might think it would work the same, but it's not going to work the same way. When I run this code now, counter count2 gets count1, what that does is it creates a new counter object or a reference to a counter object called count2. And it doesn't actually copy the counter object like we had with the primitives. Okay, there's 2 8s right now. What it does is it copies the address 123 Fake Street and essentially points counter 2 at the same object as count 1. So what's going to happen now when I go count2.add, we're going to call that method on what count2 is pointing at, which is this object here. So we'll turn the num variable into a 3 now. And when I call count1.add, it's pointing at the same object. So that 3 is then going to turn into a 4. Okay, so what's happened with this line of code here is I've basically just connected 2 references to the same object. When I call methods on both references, they happen to the same object here. That is not the case when I call num1++. That's going to add 1 to the value stored at num1, not affecting num2. Okay, so this line of code num1 gets num2 did not connect num1 and num2 together for the rest of the program, whereas this with the counter did. Okay, when I start printing things off then, when I go at system.out.println num1, we get the 9. Whoops, 9, which is what's stored at num1. When I print off num2, we get the 8, which is what's stored at num2. Again, these are different variables. However, when I go count1.printNum and count2.printNum, I get the same 4 because, again, these 2 references are referring to the same object. If that feels tricky right now, if you feel like you don't have that grasp quite yet, rewatch that part of the video. But also, we're going to be coming back to this idea over and over again throughout the entire year. So this idea of references versus objects, we'll get it down eventually. Last thing I want to talk about is the idea that we can have objects as instance variables for other objects. Let's show you an example for that. Now I've got 2 classes here. One is a circle class. It holds a radius because a radius defines a circle. It has a constructor for creating a circle with that radius, and then the methods aren't shown. All right, the other class I have here is a cylinder, and the cylinder stores a height for height of the cylinder, but it also stores a circle object, because if you think about it, a cylinder is made up of basically 2 circles on top and bottom with a height in between them. Okay, so here we have one object storing as an instance variable another object. My cylinder object has a circle object as an instance variable. Okay, my constructor then, what's going to happen is I'll pass in a circle object to set the circle along with an int for the height. Now the big thing I want to highlight here are the 2 different ways we can go about creating that object that holds on to other objects. The first way would be like this. Objects can be created before being passed as parameters. So before I pass in a circle to the cylinder constructor, I can create a circle. Okay, so circle 1 equals new circle with a radius 7. And then I can pass that circle object into my parameter list. New cylinder will pass in the circle and then the height. Okay, or objects can be created in the parameter list. We can say cylinder C equals new cylinder. And here, instead of creating that object ahead of time, we can just call the new constructor a new circle 7 followed by the height. The difference between these two methods here is in the first case, I can reference this circle 1 outside of the cylinder, whereas in the second case, the only place that that circle 1 is stored is within the memory of the cylinder, so there's no way to reach it, okay, outside of that cylinder object. All right, so that's it for our in-depth look in constructors, and yes, we did go in depth there. If your head's hurting a little bit, that's okay. Mine hurts too trying to explain all that. If you're feeling like you aren't perfect with this stuff right away, that's okay. Constructors, we're going to be using them all year long, so you're going to get used to this stuff. You're going to get better. We're going to focus on those details over and over again. So for now, do the best you can with it. Okay, get the homework open, start working on those programs, crank out some code, and let us know if you're getting stuck somewhere. Okay, it's okay to get stuck initially here. We'll get this stuff figured out by the end of the year.